Alright, here is our first pre-calc section, section 1.1 on relations and functions. Alright, here's the cost of candy bars. On the right side, or on the left side, we have the number of candy bars. On the right side, we have how much it costs. And the first thing that they ask us to do is to make ordered pairs. So easily enough, my first pair is 0, 0, 1, 1, 3, 2, 4, 3, and 6, 4. They ask for the domain. The domain are all the inputs, 0, 1, 3, 4, and 6. And the ranges are all the outputs, or the y values. So we got 0, 1, 2, 3, and 4. Now remember, if we ever have the situation where we have the same number used twice, we don't have to list them twice in the domain or the range. Once is fine. Once it's in, it's in. Alright, so they give us a domain and range in this problem. The domain is even integers between 1 and 7, so in my table here, for my domain and my range, my domain has 2, 4, and 6. Those are the even numbers between 1 and 7. And the range is 13 less than twice the domain. So y is 2x minus 13. So if I plug in 2 there, I'm going to get negative 9. If I plug in 4 in there, I get negative 5. And if I plug 6 in there, I get negative 1. They also want me to graph it. So 2, negative 9, 3, 4, 5, and 6. Let's see, 4, negative 5, and 6, negative 1. And those 3 points are the only 3 points in this example. Alright, in problem number 3, they ask for the domain and the range based on this graph. Well, we're looking for, in the domain, we're looking for all the x values. Now in this case, the lowest x value, we look left to right as I go across my graph. There's nothing over here. And then from 0 on, there's stuff. When I look in the y direction for the range, there's nothing until negative 2. And then from negative 2 on, there's all the graph, and it keeps going up. So we're going to have y is greater than or equal to negative 2. I guess I should have had the or equals. So if you have x less than 0, negative 1, or anywhere like that, you notice there's nothing. If you have anything lower than negative 2, like negative 5 for the y, there's nothing down there. So the domain, you just look at the x values, and for the range, you look at the y's. Alright, the next one asks, is this a function? And since we have, the next question says, is this a function? We have to look at all of the different places where we see the x values, since all the x's are different. That means that it is a function. For this next one, since the 3's are the same, this is not a function. Alright, we got a couple more here. Is this function or is this not a function? Well, there's something called the vertical line test. If you draw a vertical line and cross tier and across tier, so since they crossed more than once, we're going to say this is not a function. The next example has a little function notation. So we just have to put in the 1 where we want it to go, and then obviously we do the multiplication before we subtract, and we get an answer of negative 1. A little bit harder, not much, would be doing f of x plus 3. So instead of plugging in 1, I'm going to plug in x plus 3 this time. Now we're just going to simplify this as much as possible. So we got 3x plus 9 minus 4, which means we got 3x plus 5 when we combine those two. Alright, two domain problems where we have f of x equals x squared minus 3 over x squared minus 4. We only worry about the bottom here because we know that the bottom cannot be equal to 0. So most of us would add 4 on both sides, take the square root, and we get x is not equal to, and remember when we square root both sides we get plus or minus 2. So my domain is all reals except 2 and negative 2. Alright. Let's find the domain here. So we got x plus 4 is greater than or equal to 0 because the square root cannot be negative. Solve this the way we solve any square root domain problem. X has to be greater than negative 4. So that's going to be my domain. Any x greater than or equal to negative 4.